So, I think it started the recording, though I can't see it moving.
No, it is recording. I can see it here.
But normally, what happens with the recording thing, there is a number, like it adds up the time, but it's not clicking. The clock is.
I think because I see that red dot, so it's working.
Oh. So, Namaste Shashikanji
Namaste, Anurag.
and Hardika Swagatam for this course.
Dhanyavad.
Like I just told you, history of science and technology in ancient India, and I'd like to introduce you to our students. So Shashikant ji, the big connection he has with KGP and with all of you is that he's a senior, he's an alumnus from this institute, and after that he went on and achieved a lot of things in the US with big data sets and helping a lot of Fortune 500 companies. So Shashiji is amused that I've done a little bit of homework, achieve greater heights. But the connection between Shashiji and me is the fact that we both have a passion for Sanskrit, and there are, in fact, he and a certain team of them have also developed a font, different kinds of fonts and the conversion programs from in Roman script to Devanagari and to transliteration, etc., called the iTrans font. Yes. And besides that, they've done a work of compiling Sanskrit documents, etc. But I think one of the biggest specializations that he has is to be able to present the knowledge within, so the rich wisdom that is there in the Sanskrit literature as practical Sanskrit. He's able to make that bridge between that knowledge tradition and presenting it with its relevance in our daily context. So today I've requested him because he had also spoken to us earlier on about, and he's a nice article also on ancient Indian mathematics. It's what you've been looking at the last 2 days. So maybe you'd like to just tell us, Shashikanji, what you have.
Yes, sure. So I did my bachelor's in computer science in 1990. So that way I'm a dinosaur, but still alive, not extinct. So my interest in Sanskrit started in school and continued a little later. But what I mainly found was that because any deeper study in Sanskrit literature of any kind, any field, is completely missing from schools, we really don't know what all is there. And it is changing a little bit now. It was in common knowledge in educational circles, say, even till 60s and 70s. And then suddenly it just disappeared. We never talked about our own scientific achievements. And now apparently it is coming up for good and bad reasons. So what I do is, especially in this one, I mean, most of the information is available online. Actually, all of them is available online now. Even books are available through archive.org. So there's nothing I'm providing new. But there's one thing I'm providing new is how to see the whole scenario, how to connect the dots. So that is something I'll be providing new. This was also 5 years back. I had done some research for some article, and it was a surprise for me also to realize something great missing in the picture that we keep telling about Indian mathematics or world mathematics. So I think I will start now because I've been told there's limited time and I usually get carried away. But once again, I'll try to stick to imparting the passion for these studies. I don't know how many of you would have the interest or time or aptitude, but that's up to you. So let me get started now. So most of the facts are available on the internet, as I mentioned, and it's again also very important to connect the dots. So if you don't connect the dots, you just have data. When you connect the dots, then you get some insight and some wisdom, right? And the examples I'm giving are the most notable examples. There is a lot out there that will also require maths department people to be able to digest that. There's a lot of stuff. So I'm not going to go into all of them in this short introductory thing. The purpose here would be also to, one, to know the truth. Second, to have some self-respect and pride and awe at the great wisdom of this land to which we are inhabitant. So it doesn't matter whatever thinking or faith or belief or whatever are, the people of this land have done great stuff, and we should know. I mean, we know more about Greeks and Romans than Indians, right? So let us start with some examples. And right up front, the whole thing is summarized in one sentence. Is the standard of evidence required to claim transmission of knowledge from east to west is greater than the standard of evidence required for the knowledge from west to east. I'll give you one short example. There was, I think a couple of years back, there was an article, it says that zero was invented in Mesopotamia. And when you look at it in the article, it just says that, you know, there are some spaces left blank. There's not even a symbol. It was left blank, and that suggests that they must have known zero. So there are all kinds of attempts, quite a few very flimsy, to say that no, everything was there in the West. And then when it comes to India, they'll say, okay, where is the written proof? And not realizing that for a long time, everything was oral transmission in India, especially the weather does not even allow manuscripts to be saved over centuries, right? So you cannot ignore the oral tradition. But anyway, let's get into the interesting things. So you can find most of the things in St. Andrew's website. It's a UK university, beautiful University of St. Andrews. And there are a lot of Indian mathematicians. Some of them we have heard, some we don't, and we'll see a few of them. So the most popular contribution of India is the place value system and zero. So let's just get that out of the way right away. So the Greeks did geometry. Even numbers were lengths of ropes for them. So they did not actually have arithmetic. Right? They did numbers in terms of lengths, not in terms of numbers. And in India, the geometry was inspired by the Vedic Yajna Vedika construction. So different kinds of altars, designs were made. And today we might say, why this, why that, and it's all religion or whatever. But the important point is, for whatever reason, they said, I want this kind of design for this particular yajna, that kind of design for that. And these could have been something, you know, trade secret that, you know, I only know how to construct this altar. I'm just guessing here. But whatever it was, it led to mathematical and geometrical and number-wise, like arithmetic and algebra, as well as geometry. So it led to that requirement. I mean, we know that calendars were standardized much later when in Europe they found that they could not predict when is the festival supposed to be, or the harvest festival supposed to be, and it was a big mess for centuries. And then they said, we need to get good at this calendar. Compass navigation became very important, and when people were going all across the continents, across the seas, so that led to other developments. So it's like the necessity is the mother of invention. So they had that necessity. Large numbers have been used from very early on. This is very important. If you look at the Romans, the largest numbers have only a few thousand. You know, the M for millennia is actually 1,000. So today millennium is million, but it's actually just 1,000. Imagine doing maths or calculus or logarithms, space programs with the Roman numerals. And here is the logarithmic table. I'm sure none of you know it because it's out of syllabus now, but this was used by us even during JEE exam. And this actually lets you do some crazy multiplications, and you can find some roots or whatever. Ramayana has names for numbers as high as 10 power 55, and it occurs in Yuddha Kanda, Sarg 28, when Ravan has sent a spy to find out about the enemy, which is in this case Ravan. He has crossed and his army is right out there, and the spy comes back and says that you see that guy is the one who came back earlier and destroyed, burnt our Lanka. You see that guy is his brother. You see that guy is the commander-in-chief and all that stuff. And then he mentions these names. And all these names are basically starting from 100 and then 100,000, and then that is Laksha, then 100 crores, 100 lakhs is a crore, like that. It keeps going all the way till 10 power 55. Fibonacci was the first one to promote Indian place value system and the number system with 10 digits, 10 symbols to Europe, but he was completely ignored for 3 centuries. And just to get an importance of this number, this contribution, Laplace says that the ingenious method of expressing every possible number using a set of 10 symbols emerged in India. The idea seems so simple nowadays. This is maybe around 1800s, right? 1749 he was born. So it seems so simple nowadays that its significance and profound importance is no longer appreciated. Its simplicity lies in the way it facilitated calculation and placed arithmetic foremost among useful inventions. The importance of this invention is more readily appreciated when one considers that it was beyond the two greatest men of antiquity, Archimedes and Apollonius. So they hold Archimedes and Euclid and Pythagoras very, very highly. I don't know how many Indian mathematicians we hold highly in regard, right? Anyway, so let's come to some interesting problems. So one of the problem is what should be the values of currency notes or coins, so that using each one only once, you can make the sum of all numbers within the range. So for example, today we have currency notes for 1, 2, 5, 10, 20, 50, and 100. Can we measure all the numbers up to 100, and actually up to 170 or something, using a single note of each kind? So you have only 100 rupee note, 150 rupee note, 120 rupee note, 110 rupee, 5 rupee, 2 rupee, 1 rupee notes like that, right? Can you, if you go shopping, can you give any particular price, for example, 91? Can you make 91 out of them? So it is 50 plus 20 plus 10, that's 80, and then the maximum you can get is 88. You cannot make 91, right? Simple question. And you would say, what's the big deal? And the big deal is, well, you want to minimize the number of coins or notes that you print, right? And this could also apply to weights. So for example, in the earlier days, you had handheld beam balance, so to speak, right? And you had this 5 gram or 50 gram, 100 gram, like these weights, and then you have to measure your sabji or whatever, and then you need multiple of those, right? So if you use the binary numbers 1, 2, 4, 8, 16, 32, and 64, then you can actually make up every number from 1 to 127. And this is a very simple thing that in computer science, people will immediately get it, that this is just powers of 2, and that's how all the bits and bytes work. But what is the big deal about this? So this is our Ana system, the old rupee. So now we say the new paisa is what used to be called after 1957, I think. That's when the new decimal system came in the currency one. But before that, we had Ana. So so we had 1, 2, 4, 8, 16, 32, and 64 Anas. 64 Anas would make 1 rupee, right? And there's a saying in Hindi, Sola ane sach. Sola ane sach means it is 100% true. Why did Sola ane sach, right? So that is because the Sola is makes 1 rupee, which is 100%, which makes a full rupee, right? And the words we have Chavanni and Athanni. Chavanni is Char Ana, which is 25 paise. Why is that? Char Ana is 4 into 4, which is 16, and which is 1/4 of a rupee, right? So imagine that we had the system 64 based, not 60 based, not 100 based, not 50 based, 64 based, and it's not coincidence, right? We might say, oh, it's just a coincidence, whatever. It never happened anywhere else. And interestingly, this goes all the way back to Harappa. So 500 BCE, that is about 7,020 years back, Harappa had standardized weights and measures in the Indus Valley civilization. And 558 weights have been excavated from Mohenjo-daro. So different stones with different weights and all, they have been excavated, about 558 different ones, right? The bricks for which Indus Valley civilization was very famous, very, very famous. They were the first ones to actually make bricks. They had a standardized brick of 1:2:4 ratio. So 1 is the width and thickness, 2 is the width, and 4 is the length. And this standardization is a sign of great commerce. That's what happens in every civilization, that as soon as you have money, you trade with different people, you need some standardization so that there's no cheating going on or whatever. Right? So they've also found an ivory ruler in Lothal. This goes back to 2400 BCE, which has the smallest marking is 1.6 millimeter calibration, and the variation is almost negligible. There is no variation. It's very, very standardized, very precise measurement. And standardization, as I mentioned, is a sign of a flourishing commerce. And remember that Indus Valley was doing commerce all over Middle East and Europe, Egypt, Mesopotamia, and the Greeks. And well, Greeks were not there at that time, but all of the known world at that time they were trading. Right? We do find archaeological excavations, seals, Indus seals. Could somebody mute their microphone? There's a lot of noise. Okay. The Arthashastra by Chanakya also offers a lot of wealth of evidence for the wide varieties of standardized weights and measures of the time, right? And there was actually a department of standardization, and they would actually catch if somebody was using false weights or things like that, and that would be penalized. Now let's look at one more person, Pingala. So let me just first introduce the problem or the problem solution. So here is Pingala's Chandas Shastra. Very, very opening this thing. He's saying, Varasaya Kaguhara Vasudhasa. And what he's trying to do here is, when you have, in Sanskrit, and actually in every language, you have a short and a long vowel. So when you are saying some words, there is short and long and patterns of short and long vowels. Consonants are just there to give a color to the vowel sound, but otherwise it's the vowels that sustain it, right? So short and long. So when you are making poetry, I mean, we have blank verses and all nowadays, but in Sanskrit, chanda actually means that which is pleasing. So poetry or music is very pleasing, so it's called chandas. And here what he's doing is he's trying to make patterns of three varna is syllable, or three notes, and he's saying what are the various combinations possible, permutations possible of one short and one long vowel. So Varasaya, and then he's giving the name to that particular pattern. So Varasa, and why they're using like this is a very typical thing in Sanskrit. They don't use very boring stuff. They try to make it interesting. So they are saying Varasaya is Va is a short vowel, Ra and Sa are long vowel, and Ya at the end is the name of that. So it is a Ya Gana, and the Yagana is what? 1, 2, 2. That is short, long, long, and that you see here in the bracket. That it is not ISS. It is the bar is for a short matra, and the S like symbol avagraha is for the long matra. The next one is Kaguhara, is the Ra Gana, and the pattern to remember is Ka Gu Ha, so long, short, long. Vasudhasa is short, short, long. So like that they have 8, so this is Sargan. So there are 8 Ganas, and they just took the number 3 there. So let's look at what is going on here. So Chandas, as we mentioned, that Chanda itself means something that is pleasing. And Chanda Shastra is the Shastra of prosody or poetry or meters. And Pingala was born around 3rd century BCE. And his work is in a sutra style, even though it is called Shastra. It is in a sutra style. And Halayudha is another person who gives a commentary on it in the 10th century. That is one of the commentaries that is available. So all the sutra style literature is very, very compact thing. It's not like detailed lecture notes. It is just the headlines kind of thing, or just the formula and no derivation. So the derivations would be in some commentaries or discussed in the class. That is why a lot of times you find that, oh, it's so cryptic. I don't know whether they knew it or not, or whatever. You're just extrapolating things like that, because sutra is by nature is supposed to be very precise and to the point, and very, very short and concise. So the two values of a short and a long vowel, if a verse or a chanda has n syllables, right? N syllable, and syllable is it ends in a vowel. So whenever the vowel comes, that ends one syllable. So per line, if you have n syllables, how many types of patterns can be made? So for example, the very common shlok that we hear is an Anushtup Chanda, which has 8, 8, 8, 8. So 2 lines, and if you divide each line into, that is 4 pieces, each piece has 8 syllables. So the question might be that how many types of Anushtup Chand can be there, because that the Varna Vritta is length is 16 for 1 line, right? So total possible combinations for any value of n will be 2 to the power n. And again, this is now very obvious to us. It was not that obvious, thinking of not just 2, but the powers and then calculating how many. This is all combinatorics, right? Combination permutation. So we see that there are 8 possible for n equal to 3, right? And these 8 are actually given names, and these are the common pieces that are used to compose bigger verse pattern. This classification. Now, if it is 16, it will be 2 to the power 16 possible variations, but not everything is beautiful to the ear. Same thing with the musical raga. A raga would have, basically 7 main notes and 12 total notes, and then 22 shrutis totally. If you look at Indian system, there's 22 shrutis. So you could say that, even if you take 12, how many different ways can you make a raga? So it will be, how many are you picking? You're picking 5, then 12 C5, right? How many ways can you pick? 12 P5, actually, permutations. So not all permutations are actually music, because music is that which pleases the ear. Music is not any sound, right? So even though the possibilities are very, very high in trillions and all, but the number of actual ragas are only very less compared to that. A few hundreds are the most popular, and then thousands of so have actually given names to that. So this one, this one is a Pascal strangle. It's called Meru Prastar. And Donald Knuth, he's the father of computing, in the Art of Computer Programming, he mentions that Halayud in his commentary on Pingala's work mentions this. And he had actually, in his books, he says, if there's any kind of error, I'll give you $2, even including typographical error. So he didn't even make a spelling mistake. So there he had mentioned historical, and I said, okay, the very first chapter only, I said, this, he will miss it. And then I find that he has mentioned that. So it's a very well known even in the 60s and all. And this is also a binary system, because when you're doing the Gana, the short and long, there are only 2 values, and similarly in binary numbers there's only 0 and 1. So there's a clear development of binary numbers. He even shows how to convert a given sequence number, like if it is the 5th one, then how do you convert it into the pattern and all. He mentions that, which is basically division in binary system. And these are also coefficients of NCR. So what you see on the left side is the Meru Prastar. He also mentions of Matra Meru, which is Fibonacci sequences. And he explicitly mentions 0, Shunya, in the process of how to convert a number into binary pattern. I also want to give you a quick short story, and I think stories are very interesting. So this is about parallel universes. And the known universe is inside a black hole. This is the presumption. What if the entire known universe we have today is inside a black hole, and there are many such black hole bubbles? And because light cannot get out of a black hole, none of these big, huge black hole bubbles can communicate with each other, right? You cannot prove it or disprove it, but this has been postulated. Right? And they're saying that there is a possibility of parallel universes, because you can't even disprove it. So here's a story in one of the Puran, Brahma Vaivarta Puran, and in this it comes that Indra he defeats Vritra, and after that he gets very proud that I could defeat the Asura Vritta, and he wants to remember this, so he calls the celestial engineer Vishwakarma and says, we need to build a great palace. And he would visit the palace while under construction, and he will see okay, can we make this change? Can we make that change? And he was basically making, design requirement changes in the middle of the project, right? So it's not possible. So Vishwakarma goes to Brahma and says, this guy is just driving me crazy. I've not had any leaves, and I'm constantly working. What to do? And Brahma says, let's go to Vishnu. He will have some insights. So Vishnu realizes the the root problem is Indra's pride. So he says, okay, you go, I'll take care. And the next day when Indra is in his, he has moved in, by the way, in the palace, and he's still making changes, on the upper floors and things like that. So the doorkeeper comes and says, sir, there is some young Brahmin boy who has come to see you. So he's a brahmachari, and the students who would live in an ashram. So he calls him in and says, great, have some food and all, please accept my hospitality. And he gives him an asana and sits down, and the kid is having food, and he says, okay, how is everything at your home, at the Gurukul, how is your studies going? All this small talk is happening. And then the boy looks around and says, I heard a lot of things about your palace, and no other Indra previously has been able to achieve this feat of this great architecture. So Indra is kind of little like, what do you mean, like no other previous Indra, right? And then he sees, this boy sees a small, line of ants moving by, and he looks at that and he laughs and then suppresses his laughter. And Indra is very disturbed and says, why are you laughing? And the kid says, it's better if you don't know the reason for my laughter. And that makes Indra very, very suspicious and very scared. And he says, please tell me why you're laughing. So he says, all these ants that you see, they were Indras in previous births. But because of their pride, they've all become ants now. So now Indra is very, very scared that this is not an ordinary kid. He already has a very, luminous face, and he looks young, but he's not young. He's very wise and all. So he's thinking all this, and the gatekeeper comes again, says there is a saint, sage, ascetic. He has also come to visit you. He says, okay, bring him in. And then he says, okay, who are you? What's up with you? The saint says, the ascetic, that my name is Lomash, and he has a big patch of hair on his chest and a perfect circle right in the middle of the hair, the forest of hairs that he has on his chest. There's a perfect circle, no hair. So it's like very curious, So this is, who are you? What's up with you? So he says, my name is Lomash, and this is what you call, with every Indra, one hair of my chest falls down. And that's the reason I don't have any family, and I'm least interested in all these things. Because so now Indra says, okay, I give up. Who are you guys? And then the boy turns into Vishnu, and the ascetic turns into Shiva. And then Vishnu says something, that you are not the only Indra, and there's not only one Vishnu and one Shiva. There are multiple simultaneous universes, Srishti, with their own Shiva, Vishnu, and Brahma, and their own series of Indra. So this is where this passing remark about multiple universes comes. And he says, and who will search through the wide infinite of space to count the universe side by side, each containing its own Brahma, Vishnu, and Shiva, right? This comes from Brahma Vaivarta Purana. And interestingly, in 300 BCE, Bhadrabahu, a giant mathematician, discusses 5 types of infinity. A ray, a line which is 2-dimensional, a volume, and then a perpetual, and he even deals with numbers as high as 10 power 207. The American theoretical physicist Brian Greene, he's written a wonderful book, The Elegant Universe. In another of his book, he mentions about 9 different types of infinities, or multiverses, 9 different multiverses: quilted, inflationary, brane, cyclic. You can read these up, and they will not make any sense to us. Maybe when you go into astronomy or something, it might make. There's another one called Purnamadaha Purnamidam Purnat Purnamudachyate Purnasya Purnamadaya Purnameva Avashishyate, which basically is talking about infinity. And you can say, oh, why it is talking about infinity? This is just some religious or spiritual thing or whatever. But even then, there is nobody in the world who has said something like this, even for their own supreme power, that, if you take infinite from infinite, or from complete, if you take complete from complete, only complete remains. So that which is complete, right? So an interesting thing also is 1 to infinity is the outer world, 1 to 0 is the inner world, and whatever is there from 1 to infinity, if you take the reciprocal, you get a number from 0 to 1, right? So there's a one-to-one mapping of everything outside to everything inside. And there's a very interesting side effect to this, that whatever we know or whatever we discover or invent actually comes from inside, because the events always are happening outside, right? Even before Newton, gravity was working. Even before Newton, apples were falling. So the observation was always there. But what clicked in Newton's mind came from his own mind. That's the beauty, right? So everything that is newly created is already there in your mind. You just have to be picked and matched. Anyway, so let's have a quick background. And this is where I think it's very, and I'll take some more examples later on also, but this is an important part I want to cover. So the history of maths is, it's very vast and it'll never be complete. And a lot of things are undiscovered, a lot of written proofs are lost forever. A lot of civilizations didn't even have written proofs, right? So it's not possible that we'll get a complete picture ever. And the question again is, did India do anything more than the zero and the place value and the infinity? These are the standard things. We gave infinity, zero and decimal system. So how could a poor religious Hindu India, a third world country, produce anything substantial? Is the standard logic or the standard refrain that comes to mind today, right? Not before. And the interesting thing is India was never poor. It has a long history of trade, and the reason America was discovered was that people were trying to look for India. So you don't go around looking for poor countries. You go and look for the rich countries, right? Like everybody wants to go to US today. Everybody wanted to come to India at that time. And the so-called religion, whatever, the faith of the people was in harmony with the science all along. So it is very possible to have, the two supporting each other. Now, the continuity of scientific temperament and progress in this land is an interesting thing. 6500 BCE, almost 9,000 years before, in Mehergarh in Harappan civilization, we find 11 drilled molar crowns or proto-dentistry in an early farming culture. Now, if there is a root canal done, that means sugar is there, because you don't find animals having that kind of requirements, which means that sugar was there. And sugar, which is available in nature, is not causing any tooth decay. The one that is extracted from sugarcane is the one that causes problems. So, which means that 8,500 years ago, that civilization, Harappan civilization, not 2,000 years BCE, 6,500 BCE, they were already a great agrarian culture. They had settled, they had a lot of time, they had extracted sugar, they were addicted to sugar, they had a sweet tooth, they got tooth problem, and then they tried to do something about it also by trying to do some drilling and all, right? Just one little thing can give you a lot of inferences. And then we saw that in Indus Valley, the standardization of weights and measures were there, binary numbers were used, obviously renowned town planning and advanced metallurgy. So in 1968 to 96, there was another excavation done in Mehergarh and Naushara and Perak. And it has been, and this was done by some French people. So they have established that there was a continuous sequence of dwelling sites from 7000 BC to 500 BC. And after 500, we already know all our history, right? So this is also something important to keep in mind. Now, once you connect the dots, it's not difficult to imagine that the same scientific pursuit continued, the pursuit to knowledge, right? When you see that in Indus Valley, we already had the standardization of weights, binary systems. Then you have Bodhayan in 800 BC, we'll see this later, who gave proofs also for Pythagoras theorem. Pythagoras theorem was known to almost all civilizations, but still we gave one name from a Greek guy who was not even a mathematician, by the way. We'll see that. Pingala in 300 BC is doing combinations. Aryabhatta in 419 CE is doing trigonometry and a lot more, higher mathematics. Madhava in 1400 is discovering calculus, right? So there's a continuity, and this is just samples, right? There's continuously something or the other is happening. So the question is, does it make any difference now whether we know it was Pythagoras or Bodhayan? What's the big deal? It's not the greatest of things. It's so common knowledge. It's there everywhere. But if it doesn't make a difference, why call it Pythagoras theorem or Euclid's geometry or Newton's powers? Why have we given the names, right? So why should we not have an inspiration from our past, just as a matter of fact? It don't have to be proud and all. Chest thumping is not required, but we should at least get inspiration that we also were able to do. And why should these names not become household names? Aryabhatta has become a household name, but not the whole set of this, right? So the first step towards that would be that we understand, realize, and appreciate how our ancestors pursued knowledge. So there is a Eurocentric view, and in the Eurocentric view, the ancient Greeks are the epitome of logic, scientific temperament, and mathematical achievement, because when they wrote their history, they said that our guys were greatest. And we also took their statement saying that their guy is the greatest. I mean, that's a little. So the Pythagoras and Euclid are the most famous names from the ancient mathematical world we see. And I'm not going to go into details, but I'm just got some screenshots from Wikipedia, which gives you an idea of how certain these historical figures were. No authentic writings of Pythagoras have survived, right? And almost nothing is known for certain about his life. The earliest source on Pythagoras' life and brief, ambiguous and often satirical. And we take that, okay, Western accounts of history are foolproof, right? That's what we think, that we know exactly everything about the Greek and Roman things. But nothing is known about Pythagoras. Most of the major sources on Pythagoras' life and are from the Roman period. Can you imagine that 500, 600, 700 years later somebody is writing, and that we take as history? By which point, according to the German classicist, the history of Pythagoreanism was already the laborious reconstruction of something lost and gone. Right? So it is not very, very, foolproof that this is what happened. About Euclid, very few original references to Euclid survive, so little is known about his life. Right? And he is supposed to be around 300 BCE, whereas Sulbasutra is 800 BCE by Bodha, and we'll see that one. A detailed biography of Euclid is given by Arabian authors, not even Roman, mentioning, for example, a birth town of Tyre. This biography is generally believed to be fictitious. So there goes our rock solid historical knowledge about Pythagoras and Euclid. And in Euclid, one of Euclid's accomplishment was to present them in a single logical coherent framework. So although many of the results and elements originated with earlier mathematicians. So Euclid did not invent geometry. He was a great compiler and great teacher of geometry, and he supplied a lot of proofs, right? But it was not that he invented whatever is said in elements. That's very important to remember. So now let's connect the dots. How can we say that Indian mathematicians actually had an impact? That also on the world mathematical this thing. How can we say that? Zero and decimal system, let's go beyond that. So we can look at some verifiable facts from history. And I've picked up these dates from the internet of reputed colleges that say that what is the timeline of mathematical discoveries. So prior to 800 BCE, we have evidence that mainly Mesopotamian and Egyptian mathematicians in the Western Hemisphere, Indus Valley in this side of the world, or the Indian side of the world. 800 BCE, Bodha and Sulbasutra. There are 6 other sutras also, but Sulbasutra mentions the Pythagorean theorem, and it gives proofs also, calculation of square root of 2, accurately done to 5 decimal places. And interesting is to how they arrived at or calculated the square root of 2, and or the square root method also is very interesting. Geometrical construction is also there. 575 BC, Thales brings Babylonian knowledge to Greece, and then the Greek awakening starts. Right. So 500 BC, the Greek awakening is starting. 600 BC almost. 300 BCE, Bhadrabahu, we saw that he talks about 5 types of infinities. When you talk about 5 types of infinities, imagine the previous work that has gone. I mean, first of all, you have to grapple with infinity. Then you can only think of 5 infinities. And then grappling with infinity, you have to be able to think of huge numbers, right? So you don't find any of these thoughts anywhere else because they could not think of large numbers, right? Then 230 BCE, Eratosthenes of Cyrene, he develops the sieve method of finding all prime numbers. Right? So basically you keep going, and whenever you find a prime number, if you take 2, then every 2, 4, 6, 8, you just keep removing that these are not prime numbers. Then take 3, and then 3, 6, 9, 12, 15, you just remove them. That's the sieve method. After that, there's no major work, new work, comes out of Greece or Europe, except for commentaries on existing stuff. Right? The Dark Ages of Europe also coincide with this period. This is when the Dark Ages also start happening. 1202, Fibonacci writes his Liber Abaci, or the Book of Abacus, and he updates that in 1254, and sets out arithmetic and algebra he learnt in Arabia and Persia. And he introduces the Indian number system of using 9 digits, right? And nobody picks it up. I mean, they're all proud of their Roman heritage. and nobody even bothers about the system. And after a few centuries, they pick it up. 1572, Bombelli gives the first new contribution of this complex numbers. So between 230 BCE to 1572, almost 18 centuries, there's nothing original coming out of Europe, nothing. So one, why nothing original came out? And then why all of a sudden from 17th century we see hundreds of new mathematicians in Europe? That's something that we should think, that for 18th century is nothing, and then all of a sudden everything, right? So what was happening outside of Europe during this time? First century BCE, in Lalita Vistar, it mentions that Buddha enumerates to a mathematician called Arjun powers of 100. So he goes from 10 powers of 10, goes from 10 power 7 to 10 power 53. And we saw that Ramayana also has up to 10 power 53 names given to them, right? Not just, okay, whatever. Then Buddha goes up to 10 power 421, giving names to these numbers. And you give names only when you're familiar with something, right? You use them on a regular basis, only then you give them names. In 499, Aryabhatta of Kusumpura, which is Patliputra, today's Patna, he composes Aryabhatiya and gives the great values, best values of pi known at that time to 5 decimal places. A lot of other contributions that are there, which is very well known, so I'm not including the details here. He gives trigonometric tables accurate to 0.03%, gives formula for calculating the sign for intermediate angles, develops numerals, or Kuttak method also he develops. Katapayadi is the word numerals, where you use letters to denote numbers. And the reason for that is that when you are writing in a language like Sanskrit and Shlok and all that stuff, all of a sudden you don't have big numbers coming in that will break the flow of poetry, right? So he brings in letters to substitute for numbers. Great work he does. Then 628, Brahmagupta composes Brahma Sphuta Siddhanta, uses zero, negative numbers, solves the so-called Pell's equation, which will come in 1668. He is doing in 628, so almost 1,000 years before he is doing that, right? So in 762, Baghdad city that we know today was founded in 762. And they wanted to be the center of world knowledge, and they created something called House of Wisdom, a center of learning, and they invited people from all over the world. All over the world they invited, right? So in 770, 8 years after that, Kanka, he was a scholar in Ujjain. He was a scholar of astronomy and mathematics, astronomy, not astrology, right? And he was invited, and he goes there and he introduces the Hindu arithmetic and astronomy. Brahma Sphuta Siddhant was translated into Arabic and was named Sindh Hind. Siddhant became Sindh. And another translation of Indian astronomy, Alarkand, Alark is the sun, Alarkand, has also been translated from Suri Siddhanta. About 820, Al-Khwarizmi writes the book of addition and subtraction according to the Hindu calculation. He writes this book 820, right? And obviously we don't have the original Arabic, but there are translations available which refer to this book. In 830, he writes the compendious book on calculation by completion and balancing. So this is more of an algebra, right? And that's where we get the algebra or algebra, the word also comes from. The first one is addition and subtraction, which is arithmetic. And the second one is algebra. These are big, huge milestone works in world mathematical history, right? So in 850, Mahavir, he writes Ganita Sara Sangraha and uses unit fraction, combinatorics, and other fractions also. 900, Sridhar is the first mathematician to give the rules to solve a quadratic equation as we know it today. 900 CE. 1120, Edlard of Bath, he translates Al-Khwarizmi's book into Latin, which has survived. So this is the introduction of Indian maths to Europe via Arab world. 1150, Bhaskar writes Siddhanta Shiromani, which works on arithmetic, algebra, spheres, astronomy, advances operations on zero, concept of infinity, advances in permutation combination, first sure signs of differential calculation and Rolle's theorem. And I'm not making it up. This is, very well accepted and known, right? 12th century, European scholars traveled to Spain and Sicily, seeking scientific Arabic texts, including Al-Khwarizmi's previous book. 1202, Fibonacci publishes Liber Abaci and introduces Indian numbers, and nobody takes it. Around 1400, back in India, Madhava of Kerala School of Mathematics gives what later will be called as Gregory series, Newton power series, Maclaurin series, all these happening almost 200 to 300 years later. He's already giving all of them. One guy is giving all of them. And here are some of the Gregory series, and you know, if you're inclined mathematically, the formulas are also given. So all these were, and this is proved now. This is not even extrapolation. This is not even like, you know, self-pride or whatever. It's clearly proved, right? So in 1835, Charles Wish, he was the first person in modern times to realize that the Kerala mathematicians had done a wonderful job, and they discovered calculus even earlier than Europeans by 300 years. It's not like 3 years, 3 centuries, right? This is enough time for knowledge to travel all over the world in 3 centuries, right? So Wish's publication, it was unnoticed, and nobody even took care, not even the historians of maths even looked at it. Only 100 years later, back in 1940s, mathematical historians, they started looking at it, and they found that, you know, what Wish said in 1835 is actually correct, right? So I will skip on this one because I have a couple of other slides to look. Here is one important, interesting observation. The Greeks, however, did not adopt a positional number system. It is worth thinking just how significant this fact is. The Greek mathematical achievements were based on geometry. Although Euclid's Elements contains a book on number theory, it is based on geometry. In other words, Greek mathematicians did not need to name their numbers since they worked with numbers as lengths of lines. Anyway, so let us look at, so what next? I mean, now that we know that, okay, we contributed and also, what do we do now? I mean, all the information that was discovered and all is now common knowledge. It's there in textbooks. So what do we want to do with it now? So one is that if one has interest and if it is possible, one can read the manuscripts and try to see on their own if there are new insights to old problems. And these are now available. Right? IIT Bombay is also doing great work. IIT Madras is also doing great work. And then we can also get some self-respect. You know, we as a civilization, as a country, we have been, you know, infused with inferiority complex that we can do nothing. We are nothing. We were nothing, like that. And it is not so. So we should at least know what all we were able to do and where did we lose it, that scientific temperament, where did we lose it? We should get it back from our own roots, right? We can take inspirations from them. Like we take inspiration from Newton, Gauss, Einstein, or whatever, we can take inspiration from our own people also, right? And then we can awaken, arise, and advance. And if they could do it, then you can also do it, right? So I think I'll stop here. And if there's any questions, I don't know what kind of questions this might have. It's just pure facts. But if there are any questions, then we can take those also.
Sir, what's what led to the decline of the, like, all the mathematical knowledge and about the scientific knowledge that we have?
What about them? What is the question?
And what factors
what factors led to the decline?
Yes, sir.
Okay, so we can make some, you know, connecting the dots, so to speak, that there was a lot of foreign invasion that happened in India. And you will see that with that, you start seeing the decline in all knowledge systems. The whole library at Nalanda was burnt. So whatever knowledge we felt very sacred was memorized, and which was not very sacred was available in books also, right? So we lost a lot of books and a lot of learned people during these very, very troublesome times for the Indian subcontinent. And you will see that Kerala mathematics was surviving much later because the external factors started up there in Sindh, Punjab, Rajasthan, Haryana, that area first. So all the knowledge systems or places or people of North went away first. We lost that first. So we still had Kerala mathematicians, but even after, you will find that after that, they also could not continue forever, right? They also just dried up. So the invasion was one very big factor. We might want to be politically correct or whatever, but these are some facts that you cannot deny. And so the environment was not conducive for scientific thinking anymore. Like that. That's my best guess.
Shashiji, Shashiji, if I may
Yes.
also say,
Yes,
I
ma'am.
think it's also a few things that changed also. So one is also the fact of the Sanskrit language, the position of the Sanskrit language being reduced in society, especially post the colonial invasion.
Yes.
During Islamic, the Mughal invasion, and during that period, there still was, but again, they were because of the
Yes.
dominant and all, there was a preference over certain things, probably certain knowledge traditions, etc.
Right.
And I
Right.
think it's special with the British efforts to erase it from our memory.
Yes, it is well documented, by the way.
Yeah.
Not just the Macaulay thing. It's very well documented. We only hear about Macaulay, but there are wonderful the annals of British this thing. They keep publishing these every 6 months or every month or whatever. This is like 1700s, 1800s. So we have books from that time which clearly have recorded the discussions the policymakers in Britain had and how they implemented the policies. And there's nothing chest beating or whatever that, the politicization of these statements happens. It's a very, very known fact that they said. So when the Britishers did the first survey of education in India, they found that there were two types of schools. One where the Persian was the main language of teaching, and the other one was Sanskrit was the main language of teaching. And these schools were open to everybody. And interestingly, there were ironsmiths, there was a dhobi who were teachers, not just students, who were teachers of the mundane knowledge, right? Not the esoteric knowledge, but the worldly knowledge like maths or science or chemistry, alchemy. These people were the actual ones who were doing. So they were even teachers, and it is recorded. And there were girls also in these schools. And this is Britishers recording it. And then they said that the only way, and this is well documented, if anybody is doubting that, you can search on Google itself. So what they said was that if we need to get hold of their minds, we have to do something about this, the education, and education or the language is the carrier of the culture. So we need to remove these two languages from our support. We are not going to support them. They can have whatever they want. But the Britishers started their own English medium schools, started with Calcutta, and they offered the latest science and maths happening in Europe. So here we had a few centuries of no scientific temperament, just old commentaries and old stuff, just keeping that alive, but nothing new. So they brought in this thing, and they said, and there's a person also, he predicted that Indians love knowledge. So give them the latest maths and science happenings in Europe. They will love it. They will come, and then we will manipulate. It's clearly written, right? It's a 4-page article that talks about this in one of the Asiatic Society journals from 1800s. So they introduced that, and then the elites started going to these English schools, and then following that, everybody else also, okay, it's a great thing to be in English school. What we lost there was touch with our own language, our own way of thinking. That is very important. It's not bad to take knowledge from anywhere else, right? I mean, obviously Europe was doing a lot of things, but if you lose touch with what you are and how you think and how you approach some things, then there's a problem. For example, even in medicine, the Western approach has always been, individual systems, right? You break up things into parts and you learn each part and you will know. But we have always said everything's holistic. So if you break the car apart into tire, steering, and the seat and all these things, you will never know what is a car. Only when you put them together, you will know. So we have had this approach to life, a holistic approach everywhere, even in maths, even in language or science or whatever. So that is there. That happened systematically for whatever reason. So at least we should realize whenever we can and try to learn from whatever past we can learn.
And one more question. Like it is said that in the past Indian time, like the female gender were not like they they were not allowed to study. So is it true? Was it true really in the past of our Indian culture?
I don't think I got the full question. They were allowed to study. Is it true? That's all I got. What was the question?
Yes,
I'm
sir.
sorry. Who
Yes,
were allowed to study?
to the girls like other women.
Yeah, yeah, yeah. This is as early as the early 19th century. Before the crown took over, when East India Company was there, they themselves did a survey of education in India. And the reason for their reason was selfish. They said, we need to know the people we are interacting with. And the East India Company was getting good control of the land, right? I mean, the kings and all, they were defeating, fighting the kings and defeating and getting actually political control as a company. So they said that we need to know the people we are governing so we can govern them better. You need to know your enemy better, right? So it was for that purpose they actually sponsored paid projects, sending out people, knowledgeable people with a illustrator, also artist, going around. So there is one guy who went 4 different trips he made. He landed in Madras. He went all the way to Calcutta, and then that was the first trip. And then he did 3 more trips. He was roaming around India, noticing, talking, writing down, jotting down, and his illustrator guy will illustrate, oh, I saw this temple, I saw this cow, I saw that, whatever is marketplace, and that is also very well preserved. So they themselves said that these are the things, they were all, today we say caste and all, right? All castes were studying. Students of all castes were there, right? So they themselves have done it. So we don't have to believe our people. We can at least believe there, because they were doing the research for very specific reasons. So they won't lie, right, to themselves. So they were not telling us, they were telling their own people in English books. So yes, it was true. Yes, girls were also studying. But the thing is, it was not like today. See, today we have made it mandatory. Everybody has to go. What is the requirement in that person's life? So if a farmer is there, what is the point of learning about the structure of atom and chemistry and physics all the way up to? There's no point, right? He's a farmer. So our education system was catered to the person's needs. So some basic elements will be there, and after that, specific things are being studied by the individual. So somebody, if he's an ironsmith, he doesn't need to know about agriculture, for example. Just a small exposure will be fine. So he is studying something else. But basic stuff was there, the language, maths, and basic moral ethics or whatever. That was common to everybody. But beyond that, people, students were learning on a need basis. That is very important. Basic literacy was there. But since we had an oral tradition, even literacy was not very important. Education was important, not literacy. That's the way we approached them.
Sir, and if our people were smart and more knowledgeable than the Britishers, then why we couldn't understand that they had come to invade us, and why we got defeated like by them?
Good question. So now we are going into a slightly different territory, but I will address that question to whatever I have also thought about these things and all. And you will get as many opinions or simple like, okay, we are stupid, that's why we lost, right? In a sense, that is true. That's the crux of the whole history, that we were stupid, so we lost. But how did we become stupid? That is also a question, right? So if you look at the warfare and the Niti Shastra, which is the practical worldly wisdom, and Sanskrit literature, the largest contribution in Sanskrit literature is of Niti Shastra, which is practical, political, governance, administration, that kind of things. It's the largest amount. Like most written thing is on Niti Shastra. Everywhere it is. Even in Ramayana, Niti Shastra is filled up. Mahabharata also Niti Shastra. Purana also Niti. Everywhere Niti Shastra is always there. And somewhere we lost it. The other thing is that earlier in all over, well, not all over, but at least in India, when armies fought, they only fought the soldiers. Soldiers fought the soldiers. That was always there. There was never a problem to the civilians. But the external attacks that happened, They were indiscriminate, and India had never seen that. They were not prepared for that. They did not know. Somewhere somebody said that in India, war was an art, whereas in Europe, it was a science. Big difference. So here, we know, okay, our soldier will fight, we'll figure out who is the mightier one, and then you pay taxes to me. It was not like that when the foreigners were coming in. They were killing anybody and everybody. They made sure to kill the minds of the society. It's recorded in history. They made sure that the minds of the society, once they are removed, then the society becomes rudderless and easy to control. And we have seen that in very recent history in Bangladesh, when Bangladesh was born in the early 70s. Just before that, that's what was happening. The intelligentsia of Bangladesh was being removed, killed actually. So that is where I think we lost. We did not realize what the enemy was doing. We, I think, got caught up in spirituality too much. The kings should not get caught up in spirituality. They should be, practical and all. And maybe we also had some, overconfidence. Maybe, oh, who can do anything to us? Like when Alexander was coming, the emperor of Magad, Dhananand, is said to have said to Chanakya that oh, they can come and whatever they do to the border states, who cares? If they come to Magad, then we'll teach them a lesson. So Chanakya says that they is not going to look at who are Bodh, because Dhananand had become Bodh, right? He was a Buddhist. So Chanakya says that they are not going to look at you as you are Buddhist or whatever. Everybody here is an Indian for them, so they will not discriminate between two. They'll kill everybody. So that is where I think we lost that political edge that we had, and we are facing the consequences now. I don't know if that answers your question. But
Thank you, sir.
Good morning, sir. Am I audible?
yeah, please.
Sir, today in the discussion, one point came where it was told that there are five infinities. So, four
Mhm.
of them I could understand, but what is perpetual infinity all about? Can you please?
Yeah. So I have not gone into details because one is that even if it is ancient math, it can become very detail oriented. So I've skipped that. But you can look at Jain mathematics. You can do some research on the internet. It's all available. So I didn't
Okay,
want to
sir.
make it too technical. It's a,
Sir, I would like to continue on the previous note that the discussion which was just going on, it's
okay.
regarding the Britishers introducing the Western culture or the Western education system in our country. So, we Indians, why did we accept it and why didn't we raise our voice at that point of time? Thank
So, okay, so we are drifting the scope. That's fine. Just whoever has time can hang around. I think you guys have some other classes also. So this is well documented. And what was documented was, see, it all started before the crown took over. So it was still East India Company. There were still kings who were not under the East India Company, right? So, but the areas, for example, Bengal was under East India Company. So they said, and Macaulay comes actually a little later when he says that we need clerks and all. And this is all documented by them themselves. So what they said was that you cannot force all these things on these people. So how will you do it? And I mentioned that there was a colonel army guy who visited India only once. And he said that, what the heck are you guys doing? Why are you giving this financial support to schools that are teaching in Sanskrit and Persian? Because those were the schools of the locals, right? Of the Indians. So they said, no, we are doing it as a CSR, like, corporate social responsibility. We give some donation to these schools so that we are in good books of the locals. So he said that you're wasting your money. He said, you should have, and this is the guy who said that, these guys love knowledge, give them knowledge, because a lot of new knowledge is coming out of Europe, which was true. So give them that, they will come for that. And then you can teach them anything else. So they included Bible studies, they included conversion, all this stuff they included in the education system itself as a side note. Okay. So they were very shrewd in their planning, and we can't blame them. They were bad. We were stupid also, right? So I agree on that one. And what happened in Bengal? Bengal was priding itself on this intellectualism, and we are the smartest people and all that stuff. And Kharagpur is also in Bengal, so and I have been there, so it is close to me also. But what happened was they did not realize what this new step was doing. They joined, they sent their kids to these schools, they learned new scientific and mathematical stuff, and they were thrilled. They discussed like crazy, right? We all love to discuss funda as we speak, right? The gyan, the funda. That was the hook. So you can trap or entice a good guy and a bad guy. Ways will be different. So the good guy you entice with, hey, I'll give you knowledge. Let's come and discuss knowledge. And that's how they came in. It was not compulsory to go to the English schools, but if you went to English schools, then you would get a job in the company, in the company, like the East India Company, right? So that was also there. And then there are always ways, and that topic becomes big. The Niti Shastra, and it was not something that we Indians did not know what is Niti Shastra, what are shrewd people. We knew very well. Chanakya also says that. Ramayana may also, there's a whole chapters of Niti. Mahabharata has entire Vidur Niti and lot of other sections of Niti. And lot of them other like Panchatantra and Mahabharata and Hitopadesh, they have great Niti. They tell you how do you identify a bad person. And our own folks forgot our own scriptures, our own wisdom to realize who is doing what to you. That was the biggest fall in my opinion, that we did not realize what is this new education kind of school or whatever is doing. Take the good from it, no problem. Yeah, Europe is making great strides. Take it, learn it, but don't lose your own identity. That is the main point. Once you lose your identity, you are like a rudderless boat, right? Anybody can take you anywhere. I think that's where we missed out.
Okay, thank you, sir.
Sure. Anuradhaji, any other questions we have, or I think students have class also, right?
I've left already. So does anybody have any other question, or we can?
Oh, they left already. Okay, let me at least stop
Yes.
presenting them. No? Okay, so then I can also see how many people are there. Or some chat
No,
is
with
also.
MS Teams, it's quite difficult to find this. Okay, there aren't many, so I think we can close at this stage.
Sure.
Because they all have classes to attend.
Okay, I see there are 19 still in the thing. Yeah, so I'm fine. I mean,
yeah,
I think
I
should
said, like I
also.
said, so a few people have been asking for the PPT, which of course you will provide. And I was just also wanting to request you to share, let's say, the document that you spoke about, where the British are, that two-page
Yes,
document. It'll be great
please.
for them to actually, have access to these original archival
Yes,
documents
yes.
to know that there is, just a sample of many other things.
Yes.
So, yeah, I
And it
think
is
one
very
of
important for students at least to know the truth, one, and to feel inspired. You should know the reality, what happened. I mean, there's no point cribbing about the past, that, oh, we lost. Yeah, we lost. Find out why we lost. What can we do? And what did we have that we can take forward, right? And it is not just facts, it is attitude also that we should look at that. What did we have? What was our attitude, right? So that way. Sure, I'll send the supporting documents and links.
Yes. You can either share it with me and all, or even directly upload it here if that is
I'll
allowed.
share it with you, and then you can put it with it, because I don't know where to put. I don't want to make a mistake.
Please
Sure.
do that. So, yes. So, thank you very much. Just one thing, that St. Andrews is also my alma mater. I did a course.
Oh, small world.
Interesting that they have all these documents. I don't know if we have in Indian universities or Indian institutions of higher, like for example, in IIT. Do we have a record like this? Is a question.
Right.
That is what.
St. Andrews Mathematics Department website has provided beautiful information. I mean, such detailed stuff they have provided that, and so people have actually sat down and studied those works. Mathematicians with Sanskrit scholars sitting down, studying and actually appreciating, like, wow, this was there. And so, I mean, I didn't find any other website as passionate about Indian mathematicians. They have other mathematician history also, the history of all civilizations and all. But nowhere I've seen, so much information and passion about an appreciation for Indian mathematicians. So that's wonderful. I'll send you the links.
So that's what I'm saying, that it's unfortunate that
Oh,
passion that
one
we
more
have been there in our higher
I
institutions
think
of learning.
Jeet has a question. Yes, Jeet?
Yes, Jeet.
So, since we are talking about currencies today, so there was a barter system also in the history of our culture. So, did that exist in the Harappan civilization? Barter system, that is, we exchange goods in
Right,
uh,
right.
goods. Yes, sir.
So I think barter system has been all over the world, right? Because nobody was born with currency. But I think barter system became a problem. For example, today if you want to buy a laptop and you have a farm, so you say I have a wheat farm, I can pay you in wheat. And then this 60,000 rupees laptop, can you imagine 60,000 rupees worth of wheat you carry to the shop? So that was a natural, as commerce increased, the currency had to come in, and currency earlier was just the precious metals because you don't have enough of that. Nobody made just iron lumps into currency. Earlier it was gold and silver because you don't find that much, and later on it became stamped coins. So whether it was Chandragupta time or Harappan time, there were seals, right, or any material made, but a special stamp put which cannot be duplicated. So main thing in currency is you can't duplicate easily. So Harappan civilization also would have done barter system at some point of time. For example, Mehergarh, which is 8,500 years from now, from today. So they would have had some barter system, right? They didn't have, and remember also that all economies were local economies all over the world. Right, in India, especially, that 5 villages were sufficient for all regular needs of people. That was the development model. That within 5 nearby villages, you should get everything of your normal requirements. Only exotic fragrance or some exotic silk that you get from foreign lands is the only thing that you have to do. So yes, barter system was there everywhere.
Okay, thank you, sir.
Sure.
So I think Shashiji, I think that's good. I think
Sure.
thank you very much.
Oh,
Dhanyavada for
thank.
giving the
Dhanyawad.
time to talk to the students and enthuse them basically
I
with
hope somebody was awake. I hope not everybody slept off or something. And if I was able to spark any, ignite any sparks, my mission is done. Please continue this in your own private way. It's very interesting. No matter which field you are in, there's a lot that we have done.
yeah. No, I think I
Okay.
wanted to share your website. It's not there. Your
That's
website
okay.
I
I'll
had shared.
send you. Yeah, I'll send you the details. I'll
Yeah,
send you.
yeah,
Huh?
yeah.
Okay. Thank you, Anurag.
Okay, बहुत
Thank you,
धन्यवाद.
guys. Yeah.
Thank
Dhanyawad.